Okay, so delta grains per pound is 100 minus 65, which is 35 grains per pound. Okay, so by using this people, infiltration and outsider, we calculate the room latent heat. So from page number 13 again, yesterday we have calculated sensible heat, right? So this has to be changed to here. So we are taking office work as our application. Okay, in this apartments we have room dry bulb temperature is 75 Fahrenheit. As it is 75 Fahrenheit, we are taking the latent heat, so which is 205. Okay, 205 BTU per hour. So next, room latent heat, people, number of people into latent heat gain per person, which is 2 into 205, 410 BTU per hour. Next, infiltration, CFM into delta grains per pound. Yesterday, what is the infiltration CFM we got? We have calculated the perimeter of the door and window. We have taken number of doors and the number of windows. Okay, into perimeter into one, total perimeter into one. Yade, do you remember that to calculate the infiltration?
Yes, sir. Yes, sir. Perimeter, got it. Yeah.
Same infiltration value we are taking, and we have added 35 grains per pound into 0.68, which is 456.94 BTU per hour. Outside air, CFM into delta grains per pound into bypass factor into 0.68. Okay, outside air CFM, how much we got? Outside air CFM, which is 60 we got yesterday, right? 60 into 35 into bypass factor 0.4 into 0.68, which is 571.2 BTU per hour. This is the total value. Therefore, room latent heat equals to people plus infiltration plus outside air. So 410 plus 456 plus 571.2, which is 1438.96 BTU per hour. So again, I am taking a factor of safety to find the effective room latent heat. 5% I am adding as a factor of safety. So after adding 5%, effective room latent heat equals to 1510.16 BTU per hour. So हमको रूम सेंसिबल हीट भी मिल गया और रूम लेटेंट हीट भी मिल गया. ठीक है, रूम सेंसिबल हीट मिला है और रूम लेटेंट हीट मिला है. So therefore effective room total heat, okay, effective room total heat equals to room sensible heat plus room latent heat. Effective room sensible heat plus effective room total heat, which is equals to 13180.45 BTU per hour. So अभी हमारा रूम पे इतना हीट आ रहा है. Okay, we are getting this much heat in the room. Now from here we'll be defining the capacity of the machine. Okay, from here हमें machine capacity को define कर रहा है. So to define the machine capacity, first हमें define करना पड़ेगा. हमें क्या define करना पड़ेगा? So here we have taken bypass factor plus contact factor is equals to 1. So I'll come back only here, only I'll explain you. See, so this is the coil, sir. 1 minute, allow me 1 minute. Sound తగ్గించుకోవాలి కొంచెం. Okay, this is the coil. In this coil, हमें वो 60 CFM of air, outside air, ventilated air we are supplying. Okay, whatever the ventilated air which is there, we are supplying here. Now what is happening? Some air will come in contact with this coil. कुछ air ये coil से contact होता है, कुछ air एक coil से bypass हो जाता है. गैप्स होता है ना, coil का बीच में गैप्स होता है, will all the air will come in contact with this coil? No, right? कुछ एयर कांटेक्ट होता है, कुछ एयर ये गैप से बाईपास होके रूम के अंदर चले जाता है. अभी मैं क्या किया, बाहर से कितना 60 CFM है, वो कितना बाईपास हो गया, उसका वो कितना बाईपास हो गया, हाउ मच इट इज बाईपास्ड, दैट हीट इज एडेड टू हियर, आउटसाइड एयर हीट में इधर ऐड कर दिया मैं. अभी हाउ मच एयर इज गेटिंग कांटेक्ट विद दिस कॉइल? ओके, 0.3%, that means 30% of the air, 30% of the air is bypassed. Remaining 70% is coming in contact with this coil. वो 70% का हीट अभी ये मशीन निकालना पड़ेगा ना, ठीक है. सो वॉट एवर द हीट विच इज एडेड इनटू दिस रूम हीट, वो हीट भी मशीन निकालना पड़ेगा. whatever the air coming in contact with this coil, उसमें उसका हीट भी मशीन निकालना पड़ेगा, ठीक है. सो वो लोड भी ऐड करना पड़ेगा, उस पे वो लोड भी ऐड करना पड़ेगा. इसीलिए हमें सेपरेटली आउटसाइड एयर हीट का कैलकुलेट कर रहे हैं. सो आउटसाइड एयर हीट बाईपास फैक्टर प्लस कॉन्टैक्ट फैक्टर इक्वल्स टू 1. नाउ वी आर कैलकुलेटिंग विथ रेस्पेक्ट टू कॉन्टैक्ट फैक्टर. Contact factor equals to 1 minus bypass factor. Contact factor equals to 1 minus bypass factor. So sensible heat S equals to CFM into delta T into 1 minus bypass factor into 1.08. So outside air heat में हमें कितना CFM आया, उतना CFM ले लो 60, delta T 31, 1 minus bypass factor 1 minus 0.4 into 1.08, which is 1205.28 BTU per hour. सेम लाइक हमें सेंसिबल का भी कैलकुलेट करता है, लेटेंट का भी कैलकुलेट करता है. सो लेटेंट हीट L इक्वल्स टू CFM into delta grains per pound into 1 minus bypass factor into 0.68, which is 60 into 35 into 1 minus 0.4 into 0.68, which is 856.8 BTU per hour. So abhi my machine should need to remove the heat this plus this, ठीक है. So total heat हमें हमारा मशीन निकालना पड़ेगा. So now grand subtotal equals to QT, effective room sensible heat plus latent heat. So total value will be 15,359.43. So at final step, we add factor of safety as 3%. So therefore total value is 15,703.31. So 31, this is in BTU per hour. Okay. So 1 TR equals to 12,000 BTU per hour. Conversion factor. 1 TR equals to 12,000 BTU per hour. So therefore grand total TR in the form of TR is 1.30 TR machine is required to cool that room. How much? 1.30 TR machine is required to cool that room. Okay. So हमको we have classified the machines into two categories, right? Direct refrigeration system, indirect refrigeration system. Now, as we have calculated the machines as direct refrigeration system and indirect refrigeration system, now all direct refrigeration system machines are calculated, are selected with respect to the TR value. विंडो एसी होने दो, स्प्लिट एसी होने दो, डक्टेबल स्प्लिट, वीआरवी हो सकता है, पैकेज हो सकता है, वो पूरा मशीन हमें टीआर के हिसाब से सिलेक्ट कर देते हैं. बट व्हेन यू कम टू द एफसीयूज एंड एएचयूज, हाउ दे आर सेलेक्टेड? दे आर सेलेक्टेड विथ रेस्पेक्ट टू सीएफएम. सो हमें इधर सीएफएम का कैलकुलेशंस भी करना पड़ेगा. सो टू कैलकुलेट द सीएफएम, फर्स्ट स्टेप इज वी नीड टू फाइंड effective room sensible heat factor. Effective room sensible heat factor. So effective room sensible heat factor equals to QS by QT. Effective room sensible heat by effective room total heat. Okay, effective room sensible heat by effective room total heat. So which is 0.88. So by using this ESHF, effective room sensible heat factor, we'll find apparatus dew point temperature. Apparatus dew point temperature is nothing but the temperature of chilled water which we need to supply to the AHU coil or FCU coil. Getting my point? AHU FCU के लिए हमें chilled water supply करना है ना, वो chilled water का, okay, AHU और FCU chilled water का temperature कितना होना है, that temperature is called as apparatus dew point temperature. Okay, so to find apparatus dew point temperature, so I'll tell you the page number. Please allow me 1 minute. So from page number 22, if you see 22, so this sheet is representing the apparatus dew point temperature. अभी हमारा room temperature कितना होना है? What should be our room temperature? Room temperature, how much you need? Room comfort conditions. Can anyone?
Under 26.5. 22 to 26.
I'm talking about this load calculations.
Oh,
room
sorry.
conditions, what you have taken? 75 Fahrenheit, right? It's a dry bulb temperature.
Yeah.
Okay. 75 Fahrenheit is a dry bulb temperature. Dry bulb temperature 79 है. ये table select मत करो. 78. Even
No.
don't select this. 77. So where we have 75, that table directly we go. Okay. So why I am telling this? When your dry bulb temperature changes, the table changes here.
Okay.
Okay. So this is the dry bulb temperature for 75 Fahrenheit. So 75 Fahrenheit I am taking. How much RH you need in the room?
50.
So I am taking 50 here. Got it?
Yeah.
If you change the RH, again your your row changes again.
Okay.
Okay. So depending on that. So remaining automatic वही आ जाएगा. No need to discuss about that. See, we have taken HR as 65, right?
Yes.
So 65 is also coming here. See, this is simple psychometric.
Yeah.
They are already
Yeah.
So this is ESHF. This is apparatus dew point temperature. हमारा ESHF कितना है? 0.88, right?
Yeah.
Here 0.84 we have and 0.92 we have. 0.84 and 0.92. So 0.8 will come in between this.
Yeah.
Okay. 52 is the 0.84 value. 54 is a 0.92 value.
0.25. That means 53.
So approximately 53. So we'll come back. Okay. So now 0.84, 0.92, I need 0.88 ka. So how to find this basically? Okay. Just 0.84 ka 52 hai, 0.92 ka 54 hai. Just 54 minus 52. How much?
2. 2 by 8. 0.25.
Yes.
Into 4. 1.
So 52 divided by 8. 8 कैसा मिला है देखो. 1, 2, just 92 minus 84. 92 minus 84 क्या तो 8 places आता है.
Yeah.
Okay. So 0.92 minus 0.84, you will get 8 places basically. So you can divide with 8. Okay. 0.25 you will get. Add 25, the mean value into the everywhere. So 52 plus 0.25, 52.25 plus 0.25, 52.5 plus 0.25, 52.75, 53, 53.25, 53.5, 53.75, 54. So exactly the all values are matching here, right? So here 53 is the ADP. That means to the AHUR FCU, you need to supply 53 Fahrenheit of temperature. 53 Fahrenheit of chilled water, right? Okay. You need to remember this point. This point again I will talk on Monday.
Okay.
Okay, this point, this is most important. What is ADP? Completely people will get failed real time पे freshers ADP के पास ही fail होता है real time पे. Why? Because ये value after doing load calculations you can understand. I don't want to reveal that. I'll come later. Okay. So 53 degree Fahrenheit. This is called apparatus dew point temperature, which is the coil temperature now. Okay.
No. Yeah.
So now
The output of the coil or input of the coil?
no, you give the input 53 means you are maintaining the coil temperature as 53 degree Fahrenheit.
Okay, that means 11 degrees the water has to be there.
Yeah.
Okay, the input to the chiller.
The input from the output of the chiller. It
Yeah,
is
the output of the chiller. Yeah, that's, yeah.
the output of the chiller and input of the AHU or FCU.
Yeah.
Okay. Till here you are clear, right? Now, dehumidified rice. ये क्या होता है? So it is very tricky point. You need to understand. If I maintain the coil temperature as 53 degree Fahrenheit, I am telling it's a apparatus dew point temperature. Dew
Yeah,
point means
yeah, got it. The where the liquid will, I mean, like the
Yeah.
molecule start condensing.
condensing.
So,
Okay.
yeah, here the
Means
dehumidified
to maintain 50% of the humidity. Okay. To maintain 50% of the humidity, you need to maintain a coil temperature of 53 degree Fahrenheit. Okay. When the air comes and contact with the coil, outside air, I am talking hot air, it cools and also dehumidifies, right?
Yeah.
When it is cooling and dehumidifying, what happens to the chilled water? Chilled water temperature rise होता है ना?
Yes.
So उधर cooling and dehumidification, major उधर dehumidification हो रहा है. Dehumidification होने से what will be the rise of the temperature, which is defined as dehumidified rise?
Okay. That means this is the input to the FCU.
My input दिया sir.
Yeah, 53 I gave, sir.
You wait. I'll come to the next point.
Okay.
So dehumidified rise equals to 1 minus bypass factor into room temperature minus ADP is the formula. 1 minus 0.5 into 75 minus 53, which is 13.2 degree Fahrenheit. Okay. That means due to the dehumidification in the coil, the water temperature is rising up to 13.2 degree Fahrenheit. That means if you are supplying 53 degree Fahrenheit into the coil का output, so input, अभी ये जो का output होता है ना chilled water return V से, वो temperature होता है 66.2 degree Fahrenheit.
Okay, 53 plus 13.2.
Yes, that means due to cooling and dehumidification, majorly उधर dehumidification हो रहा है. Due to dehumidification in the coil, the water temperature is rising up to 13.2 degree Fahrenheit, which is called as dehumidified rise. Okay. So now, to
Sir,
cool the...
one doubt, sir. So ADP is nothing but the temperature at which we are going to give the output of the coil, right?
ADP is the input of the coil.
ADP is the input of the coil.
Yeah.
So that means 53 degrees centigrade for Fahrenheit and using the water.
You need to supply chilled water temperature.
Yeah. From the coil, I am getting 13.2.
13.2 rise होता है.
Oh, that means 66.2. I will be getting the output.
66.2 will be the return temperature.
Okay.
उधर 13.2 rise हो रहा है. Okay. See, here it is a rise.
Yeah. Got it.
Next. So at this condition, if you maintain 53 degree Fahrenheit as a coil temperature, now how much quantity of air I need to supply to maintain room temperature as 75 degree Fahrenheit and 50% RH? Okay. So this is called as CFM, dehumidified CFM. Room, effective room sensible heat divided by dehumidified rise into 1.08. So 11,670.29 divided by 13.2 into 1.08, which is 818 CFM. That means if you supply 818 CFM to the master bedroom, if, see, this point is very clear, sir. if apparatus dew point temperature is 53 degree Fahrenheit, then you need to supply 18.818 CFM. Okay. If you change the apparatus dew point temperature, again this value changes.
Okay.
Okay. So this is how we need to calculate the TR and CFM.
Yeah, sir, can you go to the previous slide?
Yeah.
Yeah, here we are taking the room temperature 75.
Yeah.
Yeah, but if the people in the room, if they decide to lower it to 70 or 65, then?
So that is the major point here. We always design at 75 only.
Okay.
Okay. In commercial sectors, people ka what I am telling is people का हिसाब से नहीं होता है sir.
Yeah, there is no individual priority. Got it.
Yeah. So we always go on the comfort basis. That's it.
Okay.
Our main motto is to maintain 75.
Okay. Suppose if it is a residential application, then if it's a hotel like that, then?
Hotel or residential application क्या होता है कि उधर हमें 70 if we also this इसका हिसाब से नहीं चलता है वो basically it won't work with respect to this. See, if I go with 53 degree Fahrenheit, the air will not be at 75. The air will be at 60 or 65. Okay. The air will be 60, 65. So that is called as grill temperature, we say.
Okay.
60, 65 का grill temperature होता है. So now we use a device called as VAV units.
Yes.
Variable air volume units.
Yeah.
Okay. It is a separate device which we need to place individual to every room.
Okay. Yes.
Now
FC
that
are
VAV install to every grill. Basically वो room में हमें install करता है. वो room का branch duct पे. Now वो VAV system क्या होता है? Which is connected to the thermostat again. So वो VAV unit में क्या होता है? It is having a heater, okay, plus it is having a what we can say motorized damper.
Okay.
So now what it will do is it will be suppose if I need a temperature of 78 or 80 degree Fahrenheit. Now what it will do is it will heat the air temperature. It will rise the air temperature. It will be monitoring through the thermostat. It will be monitoring the room temperature. If the room temperature is 80, it will stop flow the air. It will stop the flowing of the air.
Okay.
Okay.
So
again,
you say that VAV system in chiller.
Not chiller. I'll show image so that you can understand. Okay.
I mean to say the branch duct FCUs.
Yeah. Okay. इसमें ये हो सकता है. Yeah. See here, in this image, they have connected with boiler. Okay. So ये boiler का मत सोचो. This is connected with the electrical now. Electrical heater. Okay. And it is connected to individual rooms. Suppose A room पे मैं VAV box connect किया है.
This is using the chiller unit, sir.
This is the AHU.
Okay. Air
From
handling.
AHU, air is coming at 18 degrees centigrade, sir. Grill temperature is 18 degrees centigrade. 18 डिग्री सेंटीग्रेड का आ रहा है, मैं 18 का सप्लाई कर रहा है तो रूम पे 600 CFM सप्लाई किया तो रूम का बराबर 24 होगा। वो है हमारा कैलकुलेशन। अभी मैं 24 नहीं चाहिए, मुझे चाहिए एक 28। So now this thermostat is there na?
Yes.
Here I will set 30 degrees centigrade as set point temperature.
Okay.
Now what this VAV box will do is, it will heat the air, okay, till the room temperature gets 30 degrees centigrade. Once the room air is 30 degrees centigrade, this thermostat will tell to this VAV box that room temperature is 30, so that it will stop flowing the air. Okay. Now suppose my room air आपका हिसाब से 24 नहीं चाहिए, मुझे 20 चाहिए. So this VAV box, what again it will do? It will allow more air to enter into the room.
Okay.
Till the room temperature comes. Why? Because I am supplying 18 degrees centigrade, right? If I supply continuously more air, at one point room temperature will become 18 again. Okay. 18 तक मैं room temperature लेके आ सकता हूँ. Okay, when room temperature is 20 again, it will tell the thermostat the room temperature is 20, allow the normal air. So that is the reason VAV box is variable air volume. So it is going to change the quantity of air according to the room temperature, according to the set point temperature, not room temperature. Okay. So this is quite little advanced systems where we use very rarely in Indian market.
Okay.
See, even you know the projects like Amazon and Knowledge City like Google. Okay. Even at that bigger applications also, we don't have a VAV system. We have a only CAV system, constant air volume. Okay. Hope you got some logic.
Yes, sir. Yes. Here we are using AHUs. That is nothing but this is totally air handling unit. For example, if it is a chiller, assuming. So the input is from the chiller. So here also the same functionality is the same.
See,
because in the chiller we have
to this air handling unit we connect the chiller, right?
Yes, this is for the air. For example, if it is water unit, then we have FCUs. FC also same VAV box will have.
Same VAV box it will be there. There is no chiller से लेना देना कुछ नहीं होता है sir with respect to the air.
With respect to the
air, मुझे air का temperature ही change करना है इधर.
But in the FCU
all water system होता है तभी you can install VAV box.
But in the FCU water will be supplied, sir.
FCU को water supply करता है. From FCU you run a duct again, right? To the duct we install this VAV box.
Okay.
So chiller को हमें very frequently vary नहीं कर सकता है sir. Chiller is a very huge machine.
No sir, actually we have got one. I mean like we are working with one company, sir. Okay. Wherein the chiller is maximum of we can install it in 20 or not even 20, 15 SFT.
Okay.
If you want, I'll share the pictures and the video.
Yeah. Small chillers, see 20 TR, say 20 TR, 15 TR chiller also is there.
Yeah.
But in the chiller, you can't vary the temperatures very frequently.
Okay.
See, once my chiller I set to 10 degrees centigrade. Immediately I can't make the temperature to 5, right? It takes time.
Yeah, it takes time.
So chiller से हमें कुछ लेना देना इधर air को air का हिसाब से chiller से हमें कुछ लेना देना नहीं करना है. Whatever you want, you play with the air, not with the water.
Okay.
Water cools down very slowly, heats very slowly. But air ko very fast you can cool, very fast you can heat. The conductivity here.
Yeah.
So that is the reason. Okay.
Okay.
Sir, hello.
Yeah.
Sir, but in hotel industries, if they are using this kind of ducts, how is that convenient for them? Like without VAV system, as you said, majority of them use.
It's basic. That is the reason आजकल when we are not able to have our own convenient systems, so the market is captured by this is the major reason we are having more VRF systems in the hotel industry. Okay, individual units, all hotel industries आजकल moved into the VRF systems. Only these systems are executed. Which systems? AHUs are executed in the applications where like airports, malls, bigger applications where the VRF system is not feasible. Suppose if you take a mall, from where you are?
Sir, you generally in the malls, it is always better to have a chiller or AHU, sir.
Yeah, chiller
I'm
is
from Mumbai.
for AHU also you need chiller, for FC also you need chiller, sir.
Yeah, good. I mean, like, FCU, for example.
No. For see, if it is an auditorium, it is a big open place. Okay, you go with AHUs.
Okay.
If the bigger loads, suppose मैं एक application बताता हूँ, which is a combination of both. Okay, I'll come to the hospital, like Yashoda Hospital. Yashoda Hospital में how it will be divided? We have a big receptions, inpatient wards.
Yes.
Okay, like it's a inpatient ward means ICUs. ICUs also will be very huge. It won't be individual. It will be single ICUs. Okay, where 15-10 people can be accommodated at a single place. Okay, so these are the bigger applications. Cafeterias. Okay, these applications we connect with AHU. And now, if you come to the inpatient rooms, individual rooms, now you can't take action that you can install the AHU. Why? Because वो room full होता है नहीं होता हमको मालूम नहीं. So at that applications we go with FCUs, but all are connected to chiller only.
Okay.
See, mall पे भी same है. Completely where open spaces we install with AHU. All the open spaces.
In the AHU also we can have this one, right? Individuals. I mean, like, why we can't have AHU in the a separate ICU, sir?
If you want, you can install. It's not that you can't have a separate AHU.
Okay.
You can have a see, if I have 5 floors, 5 floors के लिए एक floor के लिए एक AHU select कर सकता हूँ मैं.
Okay.
There is no restriction. But when the load is, see, when the individual load is 1 TR to 3.5 TR. Suppose वो room है sir. मेरे पास inpatient rooms एक 50 है.
Yes.
Each room का 2 TR है. There I can't select AHU. I can select only FCU there. Individual load है ना. So even you can say, sir मैं 50 units से 2 TR है, 100 TR का AHU लेके उसको भी connect कर सकता हूँ ना. But waste of energy, right? 50 rooms में सिर्फ 25 units ही 25 rooms ही working है. 25 units no patients are there. It's closed.
Got it. But at the time we can opt the AHU, right? Individual AHU.
वो 25 rooms को भी चाहिए ना.
No, whenever it is used, then only I got. We'll do after the class. I have this done. We'll discuss it.
Yeah. So this I'll come. Okay, we'll discuss when we come to VF systems.
Sure, sir. So generally, as you are designing, sir, what is the general considerations you take, sir? AHU, FCU, and gas like R32. Which one you prefer, sir?
So it depends on like I told you just now.
I got it. Generally, if it is preferable, then
type of the application. See, hotel industry. Just now you ask, what is the criteria? So hotel industry, why? Because every rooms they need an individual comfort level चाहिए. Okay, वो room पे कभी close होता है, कभी वो load होता है, depending on the load. So it is better to opt VRF system where it is very flexible.
So okay. VRF is a system, but the
VRF.
Yeah, VRF is or VAV. Okay, it's all nothing but from the gas. What I mean is, you prefer the regular Daikin or all this one, or generally go with the AHU or this chiller units.
That is what I am telling, sir. If it is a hotel industry, I go with VRV system. VRV system भी ऐसा होता है. If I am dealing a project, my company will be. If I am there, if I opt VRV system, I'm the consultant. I opt VRV system. मैं VRV system opt किया तो मेरे को vendors होता है.
Yes, Daikin, O General.
वो जनरल डाइकिन. I work with casting again. This is my project. इतना TR का machines चाहिए मुझे.
Okay.
ठीक है. So एक बंदा एक quotation देगा मुझे.
Yeah, which is the best company, sir, as per you? In terms
So
of
Daikin is the best.
Okay.
As per me. But depending on the clients, every machine. Yeah, air conditioning field पे best. ऐसा कुछ नहीं सर. They work on a single principle.
Okay.
Okay. But आजकल मार्केट पे डाइकिन ज्यादा चलता है क्योंकि दे हैव गुड क्वालिटी. दैट्स इट. इट्स कंप्लीटली माय ओपिनियन.
Okay.
Sir, they are just the pioneer of VRV, but I don't feel they are the best one.
वही बोल रहा हूँ ना. आपको कोहली पसंद हो सकता है, मुझे सचिन पसंद है. Okay. You have your own consideration. I have my own.
Yeah, sir.
That's it.
Opinion is subjective.
Yeah, subject to individual.
Yes,
Please, it's a disclaimer, sir.
Yeah.
कल मत बोलो मेरा सर वही बोला है मैं वही लेता हूँ. ऐसा नहीं होता है. Depending criteria, availability in the market, many things again it comes. Yeah, you can make a note of this. One more slide. I need to go back. Yeah, from here you can make a note. See, Gulf countries. If Nur Muhammad Imtiaz, you are from where? Oman, right? Or Ibrahim? कोई एक ओमन से है.
Yes, sir. Oman.
कौन है? मोहम्मद, right? या ये उधर ज्यादा चलता है तोशिबा का चलता है मेरे हिसाब से. नहीं तो मित्सुबिशी का चलता है. So depending on the location.
So वो जनरल चलता है सर. वो जनरल and
वो जनरल is completely Dubai based company. वो जनरल का चलता है.
And Panasonic, sir. We are dealing with Panasonic actually.
Yeah, depending on the location also the criteria changes basically.
Sir,
yeah, tell me.
When is our last class, sir?
Mostly I don't know, sir. I am going like fast only. So we have still more topics to complete.
Okay.
Mostly 28th will be there, your last class.
Okay. You can extend, sir. You can go slow, no issues.
And in between, I may take 2 days leave, sir.
Okay, sir.
That we'll consider on Sundays. We'll take this Sunday also. I'll take class.
Okay.
Why? Because I went to my hometown 1 year back, so I'm taking vacation leave for 3 days.
No problem, sir.
Okay, in the Christmas time. So
No,
I'll cover.
RSC can take on 29th and 30th, sir.
No.
Okay.
29, 30 again. I need to come back on Christmas vacation. I'm going.
Okay, sir.
I'll be there. I'll take 2 to 3 days. 2 days only, which is Saturday on Monday.